Howdy. My name is Jason Ballard. I'm one of the co-founders and the CEO of Icon. If you could put yourself in my boots right now. It was not that many years ago at all when this seemed like the craziest idea in the world, like just this side of science fiction, to build houses with robots. And here we are today. I am so honored that you've come to be with us to hear what we have to say about some really, really exciting things. But what makes me maybe even more excited about, I can't believe the room is this full. What makes me so excited about you all in the room today, it makes me feel like there are thousands of people who care about these things, who care about this thing called the global housing crisis, who care about what we might do to solve it and what incredible possibilities we can create for ourselves. And I want to talk about that global housing crisis for just a moment. So we've been building with sticks and bricks for about 1,000 years. And we're pretty good at it, actually. And that's actually the problem, because homes are too expensive right now. We don't have enough of them. They are environmentally problematic. They're increasingly not fit for purpose of the modern world. And because we're so good at building this way, it's not clear what we do next. I mean, the materials are well understood, best practices are well established, and the supply chains are quite efficient. And so the only levers conventional builders have to pull as they try to respond to this demand for more affordable housing, they can reduce the quality of the materials, they can reduce the quality of the labor, or they can reduce the quality of design. And that's about the only levers we have to pull. But they are trying. They're pulling those levers hard. As an effect, even as housing is getting more expensive, it's actually getting worse. And so as a result, municipalities, regulatory authorities, cities and towns are regulating with increasing fervor. And this actually has the sad side effect of making the problems worse. It slows down the process. It makes it even more expensive. So builders and developers pull those levers even harder to try to make housing more affordable, and the regulations come even harder. And I call this the housing doom loop. And the result is uninspiring, soulless, boring housing of lower quality and rising price. And we have to break out of this housing doom loop. And the way that we break out of it is tricky, because you can't just make it cost less, because they're trying to do that already. You somehow have to make it cost less at the same time you make it better. And that's a real trick. The further social consequences of this are, of course, that often the homes that we build are not fit for purpose in the kinds of places that people like to live today. And then the people that suffer the most, of course, are the very poor and the most vulnerable, the people who can't buy their way out of the problem, the people who don't have a social network to help them out of the problem. They're the ones who suffer the very most. And if you zoom out globally, this isn't just an American problem. 1 in 7 of our sisters and brothers globally live in housing that if they were people you loved, you would not stand for. You couldn't stand it. It's housing without dignity. And so we've got to solve it. And that's what Icon was founded to do. So I didn't come here today to depress you. It's going to be a really exciting, special day. So stay with me. Yeah. But there's another special reason that today's a special day. So like a special, special reason. And that's because March 12th is exactly the 6-year anniversary of the day that we unveiled the first permitted, occupiable 3D printed house in the world. Today. We did this in partnership with a remarkable nonprofit called New Story. They are pioneering solutions to provide housing ownership to the most vulnerable people in the world so that they can own their home, so that they can own their future. And so I'm proud of this house, not only because it was the first of its kind and kind of helped people believe that maybe there was some hope on the horizon. I'm proud of it because from the first day, it signaled our intention to put the people who needed help the most at the forefront of our work. And then last year at South by, in continuation of that mission and theme of Icon, we announced Initiative 99, or as we say in short, I-99. This was a global architecture and design contest to design homes that could be built for $99,000. And it's been a year, and phase 1 has completed. And I'd like to invite to the stage ICON's Vice President of Building Design and Performance, Melody Yashar.
Hi, everybody. For those of you that haven't heard, Initiative 99 is a global competition that we launched at South by Southwest of last year, asking architects all over the world to design a home that could be built for less than $99,000. Since that time, we actually took upon ourselves to answer the question as an internal research and develop initiative. And we wondered, what's the best home that can be built for $99,000 or less? In late 2022, when some of the breakthroughs that you're about to see came to light, we started to see that the results were very interesting. And it was at that moment that we decided to ask ourselves, well, how exactly would the world design a home for less than $99,000 without compromising beauty, comfort, sustainability, or resiliency? So, to gain the attention and the best efforts of the global design community, we decided to put out a very large prize, which we knew is atypical for social housing competitions. So we wanted the best, and to get the best, we knew that we needed to offer a prize that would be comparable to the money that a firm or an architect or a designer might win for a major public commission. And so we offered a $1 million prize purse, which I believe is the largest prize ever offered for an affordable housing design competition. Yes. We also assembled a team of world-class judges for the competition. They are Dr. Michelle Addington, former Dean of Architecture at the University of Texas, Lucia Athens, Austin's first Chief Sustainability Officer and author of The Sustainability Revolutionists, Michael Bell of Columbia University, Shajay Bhushan, Associate Director of Zaha Hadid Architects, Alejandro Guerrero, Department of Architecture at UCLA, Brett Hagler, co-founder and CEO of New Story, Mariana Ibanez, chair of UCLA's Architecture and Urban Design Department, Bjarke Ingels, co-founder and CEO of the Bjarke Ingels Group, Michael McDaniel, director of design and strategy at ICON, and Mark Norman, associate dean of the Shack Institute of Real Estate at NYU, and myself as chair of Initiative 99. This is an incredible lineup of jurors, and we thank them for their time and their expertise in evaluating the submissions and helping us think about sustainable, affordable architecture and home design. So now, yes, thank you. So now, please join me in taking a look at some of the Initiative 99 finalists and their stories.
My name is Juan Felipe Molano, and I currently reside in Bogota, Colombia. I decided to enter Initiative 99 because I am really passionate about the housing crisis, especially here in Colombia, because throughout my life, I've been able to really experience and see what people go through when, due to violence or opportunity, they're forced to move into the city. When I stumbled upon Initiative 99, I saw it as the perfect opportunity to really explore what a new construction technology can introduce and can help solve this crisis. When you talk to people, you get to understand their struggle as they move from a farmhouse with open space where they can garden into a really crowded space. What I really try to do is try to implement the characteristics of their original home into an urban home, a smaller one, but one that they can really appreciate and feel at home, have an open space, but also feel part of the community.
My name is Alexandre Dubord. I'm co-director of the 3DPA program, where the students have developed the project Casa Famille here in Barcelona.
I'm Justin Hanlon, a Canadian living and studying in Barcelona. I've been interested in 3D printing for a long time now, and I've been following ICON pretty closely. When I discovered they were hosting a major competition that brought together 3D printing, design, and the potential to make better homes for more people, more affordably than ever before, there was no way I wasn't going to participate.
We believe we had found very beautiful answers to the question of 3D printing architecture and wanted to challenge ourselves. So the project Casa Famille that have been developed by our students had a design inspired by this question of density. So how can you deal with packing as many square meters possible in a space, trying to make them as affordable as possible, yet creating a beautiful space for the families that live in it, respecting the privacy, creating common areas that share among us.
I'm Victoria Rozhnowski and I live in Berlin. I'm currently writing my master thesis on a 3D printed facade system at the Technical University Berlin. I decided to participate in Initiative 99 because I love 3D printing and it excites me to see how this technology unlocks previously unthinkable ways of designing and constructing. The target group is very personal to me because I come from an immigrant family. My parents fled Poland 40 years ago and lived their first year in a refugee shelter. While I was designing, I had the refugee families in mind that come to Germany to seek a brighter future. So I tried to design something that was meant to be permanent from the beginning, where refugee families can feel safe and start a new life here.
I am Mona Peters.
I'm Sebastian Contreras.
And we both live in the beautiful capital of New Zealand, Wellington. We've seen the stagnation of the building industry globally for decades now, and we believe that 3D printing can be a real game changer. And the opportunity to collaborate with ICON, with this cutting-edge technology, we knew we just had to enter and get involved. The project basically focused on two challenges. The first one is climate change, specifically the aspect of flooding, because in New Zealand, 66% of the population live in flood-prone areas. And the second challenge is the housing crisis. At the core of the story of our project is the term water. Why home is the name, and why means water in Maori, the indigenous language of New Zealand.
And water is included in all of the sense here in the project. Pillar, roof, collect the water, the cutter is here, the tank is underneath to the house. We want to try to create a design in all of the aspects in relation to the water.
I'm Colin McGeady, co-director, co-founder at For Everyday Life, and I'm based in London.
Hi, I'm Jorge Méndez Cáceres. I live in Brooklyn, and I'm a co-founder.
So we were keen to participate in the Initiative 99 competition. We saw the opportunity to really express our feelings around emerging technologies within our industry, but also respond to, emerging issues around affordable housing and displacement.
Our design was a response to displacement by natural disasters. So instead of us looking into a solution that it was temporary, we looked into how can we make resilient homes for people that have been displaced. Being from Puerto Rico, hurricanes are an issue that happens every year. And we wanted to find a solution for good housing that is resilient enough to deal with that for displacement.
I'm Paul Clemens Bart. I'm co-founder of the architecture and design practice Better Realities, and we are based in New York and Berlin.
My name is Marvin Bratke, and I'm running the Berlin branch of the office where we are also right now. We decided to participate in ICON Initiative 99 because it combines future technology with affordable housing.
So our proposal for the ICON Initiative 99 is called Collective Parts. And it basically is proposing a series of building blocks to precede the full building and therefore can allow for really a wide range of affordable housing scenarios. The history of our studio is actually rooted in affordable housing, so we are really excited of implementing some of our ideas of affordable housing by enabling them with ICON's innovative technology of 3D printing.
Wow. They're really incredible stories and so inspirational, and I'm so proud and so happy that Initiative 99 could bring this community of designers together. Initiative 99 was made possible due to the support of our lead sponsor, Wells Fargo. Thank you for helping to make such an ambitious effort possible. Wells Fargo has shown a true commitment to making real progress in affordable housing. I'd like to welcome to the stage President of the Wells Fargo Foundation, Darlene Goins.
Good afternoon. Thank you, Melody. Thank you, Jason, and the entire ICON team for having us here today. We are honored to share the stage with you and all these amazing innovators. At Wells Fargo, we believe everyone should have access to a safe, quality, affordable place to call home. And through the Wells Fargo Foundation, we aim to help historically marginalized communities gain access to economic advancement and generational wealth by focusing on 4 main areas: housing access and affordability, small business growth, financial health, and sustainability. And we focus on housing access and affordability given the significant and persistent housing challenge that exists in our country and here in Austin, Texas. It's clear that we need game-changing ideas to solve this housing challenge. More than ever, we need to be intentional about seeding innovation that will unlock new ways to accelerate housing production so more people can have a home. On behalf of Wells Fargo, we are thrilled about this new partnership with ICON to support Initiative 99 and the social innovators who are disrupting the housing market. This is an investment in truly making a meaningful impact on people's lives. It's so exciting to think about the potential of I-99 and all the lives that will be impacted because of your vision. ICON's innovative 3D printed technology paired with these beautiful, imaginative I-99 designs represent a model for the future of affordable housing.
And now we are so excited to announce and award the winners of the I-99 Phase 1 competition. So we're going to begin today with our amazing winners in the student category. From Berlin, the 3rd prize winner of the student competition is Victoria Rosnowski. From Colombia, the 2nd prize winner of the student competition is Juan Felipe Molano. Thank you. And from Spain, the 1st prize winner of the student competition of I-99 is IAAC's Team Casa Fami. Now, moving on for the professionals in the open category. From Germany, the 3rd prize winner of the open competition is Beta Realities. From the UK, the 2nd prize winner of the open competition is For Everyday Life. And from New Zealand, the 1st prize winner of the Phase 1 Initiative 99 competition is MT Space Studio. Congratulations to all of the Phase 1 winners of the Initiative 99 competition. We are so excited to kick off Phase 2 with all of you starting next month. And before you leave the stage, we have a very special surprise announcement to make. With the help of Wells Fargo, we are so excited to announce that one or more winning designs from the next phase of this competition will be realized this year in a few special places very near and dear to our hearts. First, we are ecstatic to share that we will be returning to Mobile Loaves and Fish's Community First Village. One of the most innovative communities in the world, their 51-acre master-planned community provides affordable, permanent housing and a supportive community for men and women who are transitioning out of chronic homelessness. And it's become the largest community-based model in the country, designed specifically as a place to call home for those who are currently living on the streets in Central Texas.
As a part of our focus on housing innovation, Wells Fargo is contributing $500,000 in grant funding to Mobile Loaves and Fishes to help build the first I-99 designed homes to serve the underhoused. They'll serve the underhoused in the Central Texas community. So one of your designs will now become a reality in the real world. And multiple units will be printed within Community First Village's future expansion.
But wait, there's even more. So we announced last year during South by Southwest that we will be partnering with design visionary Liz Lambert to reimagine and redesign the El Cosmico development in Marfa, Texas. And as part of the overall project, we are so excited today to also share that we'll be working with Liz and the team to print Initiative 99 designed homes where the existing El Cosmico sits today in the city of Marfa. So one of your designs may one day be part of this incredible development as well. Sit tight because we might have even more announcements to make about Initiative 99 later in the show. Congratulations to all of the winners. Thank you so much for your work and your designs and your commitment to this initiative. We appreciate it, and congratulations.
What we do here, in the kind of future it makes possible, people will feel that and they will get to live in that world.
Tu house, mom. ¿Puedes abrirlo? Wow. It's beautiful, right? Thank you. It's okay, mama. You deserve it, madre. It's beautiful. Oh, it's beautiful.
Thank you again to Wells Fargo for your support of this very important work. Alan Graham, are you here? Alan Graham? Hey, man. What you and the team have accomplished out there at Community First Village is nothing short of a miracle. Thank you for having the courage to invite us out there to support the work. Liz Lambert, you here? There we are. Liz, you are the queen of cool, and it is such an honor to be a part of everything cool you're doing out there in Marfa, including bringing affordable homes to that community that means so much to you. Thank you for inviting us there. To all the award winners, a giant congratulations. And I hope, one more round of applause for the winners. I hope you feel it. I hope you are feeling what innovation and innovative design can mean for the future of this world that we live in. And so I want you to keep those hearts open. Hope your hearts have opened, and I want you to keep them open. And I also want to ask one more favor of you, and that's that you keep your mind turned on. Because we're going to talk in some detail here about what it's going to take to solve this global housing crisis and create an incredible future. We're going to talk about some scientific detail, some engineering detail, some construction detail, some financial detail. Because I want us to all be on the same page about what needs to happen here so that we have some context for the amazing technologies we're going to be unveiling today. So houses are too expensive. I don't think that's very controversial. But how much are they? Well, according to the latest data from the National Association of Home Builders, the average cost of a new home in America is $650,000. And as I said earlier, it's almost certain that house represents like an inferior home to houses that were built 25, 50, or even 100 years ago. It's a sad state of affairs, actually, that if I offered you a brand new home that was just built in Austin, Texas, or a 100-year-old home in Austin, Texas, you actually might want the 100-year-old home. And that's a problem. But as you see here, it's very complex. There's a lot of parts in the process. And so where do you start? Of course, the biggest bucket of that is construction. Construction of that $650,000, construction represents about $400,000 of the cost. So for sure, that is the place to start. And it was the thesis of ICON from day one that we could increase the speed, lower the cost, and increase the quality of housing with robots. But that would be a lot of robots. And so as a young company, where to start? Well, if you look at that data even further, and you say, like, which robot should we start with? Should we have painting robots? Should we have drywall hanging robots? Like, what should we do? You sort of see very quickly that the most expensive part of home building is the wall system. The wall system is the most materials intensive, it's the most labor intensive, it's the most complex, and it's also, the walls create the shape and form of the home. So it's a very powerful place to automate. And so we looked at all the different ways we might automate the home. I'll spare you all of the research, but we landed on 3D printing because we believe 3D printing had a simple material supply chain of abundantly available materials, that it was inherently good building material that it would use, and that the building material was applied, it was deposited, it was built in fluid form, so you would sort of keep open all these design and creative possibilities. And so we got to work. But one more thing, I want us to make sure we're all on the same page about what we mean when we say a wall system. So this is sort of what ICON has to replace. So the typical wall system in an American home involves framing, drywall, sheathing, moisture barrier, siding, and trim. So we believe we could replace all of that with a single automation. And the average cost of that wall system in America today, according to the National Association of Home Builders, is $35 a square foot. But again, we said sort of we've got to raise the quality as well as lower the price. So what is the quality you get for that $35 a square foot? Well, you get a wall system that is R13, so R value is a measure of energy performance and human comfort. This is the bare minimum in building code. So in other words, it's kind of it's as bad as you can possibly get away with. It has no wind load rating, has no fire rating. It is termite food, mold food, and if water gets in there, forget it, it rots. That's what you get for $35 a square foot, and that's the way we're building this whole country. Our thought is that we could replace that with something that's inherently strong, inherently high-performing, with a simple printed structure and the necessary reinforcement to make it safe. We would do that while holding ourselves to a minimum standard of performance as we design the way that we would build. So at ICON, all of our wall systems are at least R22, which is a 50% improvement over building code in conventional wall systems, 200-mile-an-hour wind rating, 2-hour fire rating, termite-proof, mold-resistant, flood-resilient, standard. And our challenge, yeah, pretty dope. We committed to ourselves years ago, we would never build a wall worse than this. And the challenge is to do that for less than $35 a square foot. So I'd like you to go on a journey with me, and let's see how we did. So in 2018, as we already said, in partnership with New Story, we built the first permitted, occupiable 3D printed home in the world. The printer, prototype printer worked. The material delivery system never quite worked, so we loaded the concrete in with buckets, and we call it artisan 3D printed. The labor was basically all free because me and Alex and Evan and our buddies kind of all volunteered. But if you sort of actually put a price on all that labor, we delivered the home's walls for $315 a square feet. I would whistle, except it would hurt your ears in this microphone. It's too much. Still too much, but amazing progress, amazing place to start. That was enough for News Story to believe we could go down to Mexico and do something with them, but they wanted to prove that an improved version of the system could actually function properly. And so we were invited out to Community First Village, who you've heard of so much about today, to do our first project home out there. This home was about twice as big as the first home. We did it in half the time, so about a 4x overall performance improvement. And we did it for $245 a square foot, making some progress. Felt like that was good enough to go down to Mexico with News Story to deliver the first pilot community of 3D printed homes in the world. These homes were delivered for people living in deep poverty in the state of Tabasco, Mexico. We printed these homes 2 at a time. And interestingly, this structure was built in a seismic zone. And not long after we completed the project, the area received a magnitude 7.2 earthquake that caused extensive regional damage. And there was no observable or perceivable damage to the 3D printed homes. And we are very proud of that. Yep. We are very proud of that because how rarely that is the story for the very poor. That they get to be the beneficiaries of advanced technologies and breakthroughs in material science. We did that for $245 a square foot. Same printer, same price. Came back to Austin and earned a welcome back out to Community First Village. We did a series of 6 homes for people experiencing chronic homelessness in the Austin area. We printed these homes 3 at a time, and all 3 designs were different. It was a chance to show how you can increase diversity because the robot doesn't care about the shapes that it prints. These were the first permanently occupied 3D printed buildings on Earth, actually, and we did that for $175 a square foot. The walls. And then we thought we had made enough progress in our quality and our processes and our testing to bring 3D printing construction to the open market. And so in partnership with a group called 3 Strands, we built this project on 17th Street in East Austin. These were the first 3D printed homes ever sold on the open market. And it was a great triumph for us to know that you could really put these homes out in the world and that people wanted them. We were also able to validate our wall system for multi-story construction. That's going to become important later. We were able to deliver this project for $175 a square foot. But now we're really feeling like we're making some progress. And so in partnership with Lake Flato, the legendary Texas architecture firm, we designed, Lake Flato. We designed and built the award-winning House Zero. This was the first house ever explicitly and specifically designed to be 3D printed. What I mean by that is, it was designed to take advantages of what 3D printing offers. You had sort of these interesting organic forms that created beauty, but also created increased strength in the wall. You could make the walls thicker at no additional cost, make them more energy efficient. And so although our costs on this project for the walls were $160 a square foot, there was an important milestone besides the awards the home won and how beautiful it was. It was the first home we ever built that we don't think you could have built more affordably with conventional construction. So it was a nice little milestone. All of this got the attention of perhaps the most capable, the largest, the most effective, the most innovative production builder in America, maybe even the world, Lennar. And together with Lennar, we endeavored to build the first 3D printed neighborhood in the world in Georgetown, Texas, at a project called Wolf Ranch in the northern part of the Austin metro area. When we started that project in 2022, we were at $90 a square foot, and now, as we come to the end of that project, this past year, we have reduced our costs in half, cut our costs in half, and we're finishing this project at $45 a square foot, real world numbers. Big thanks to Lennar for helping us learn all the lessons about what you need to do to deliver homes effectively and affordably out in the real world. And as you guys can feel, we are really closing in on that number we've been chasing for 6 freaking years. When you arrived here today, you walked under the very latest version of our print suite, something internally. It's a little bit inside based. We call it Vulcan Block 4. It's the 4th version of this version of the printer. And with Vulcan Block 4, we are delivering wall systems at $34 a square foot. Hold. And so if you look at our progress over the past 6 years, we have reduced our cost 90%. And I believe I can stand here with a straight face and tell you that the Icon way of building is the fastest, most affordable way to build a wall of acceptable quality in the world. And I want to pause here for a moment to say a tremendous thank you to the whole team of women and men at Icon who have labored, hundreds of them who have labored for the past 6 years to bring this technology to the world. You are the most incredible people. You have been courageous, brave, intense, and high velocity. And I would not be standing up here with you today. Your work is a blessing to the entire world. And I believe Icon is the most pound-for-pound innovative company in the entire world. And we will see if at the end of this presentation you agree with me. Team, I love you so much, and thank you for everything you've done. So next, we get to go on some adventures with the Queen of Cool. Out in West Texas, we're taking the Block 4 printers out to West Texas to build the El Cosmico project. It is our most ambitious, most exciting project yet. It includes hospitality. It includes elevative, innovative homes, the likes of which the world has never seen. And of course, as you heard earlier, the current El Cosmico in the second phase of the project will be redeveloped as affordable housing. It really is giving us a chance to sort of stretch our wings out and show the world what we can do. And it's the most beautiful and ambitious architecture we will have ever delivered, thanks to the creative work and the collaboration between Liz and Bjarke Ingels and his team at BIG. It is going to be an incredible project. Liz, we look forward to seeing you out in West Texas soon. And so now, fastest, most affordable way, not bad. And we think we're ready to begin taking this technology out to the world, further afield, leaving our little local neck of the woods here in Texas. But before we do that, there's one more thing we wanted to be the best at. And that is, when you build something as large as a house, and when you build as many of them as we think we need to build, you're going to have an environmental impact. And so as we start to scale up in a very aggressive way now, we wanted to make sure that we are the most sustainable way that you can build. We believe we're already the strongest, the most energy efficient, the longest lasting, and the most resilient. And so the primary area that we needed to work after the big challenge, of course, you know what we've had to focus on for the first few years is just simply making the material printable in the first instance. But now that we've got that working pretty well, we think, where we're turning our focus is on reducing the carbon footprint of the material that we build with. So a couple years ago, very quietly, we started an internal initiative called Carbon X, and we have some very exciting updates for you today.
Concrete is the most produced material in the world, second only to the production of clean drinking water. The production of cement in concrete contributes to 7% of global CO2 emissions. We've been working on this new formula, Carbon X, for over 2 years.
We're here in Printland, which is our facility for testing our new products, new formulations. So what you see here is the validation of our newest product, which is Carbon X, with a low carbon footprint.
So when we compare the operational carbon emissions of a traditionally built home, a stick frame specifically, to an Icon 3D printed home, we're looking at a roughly 2 to 6% reduction in CO2 emissions.
So the CarbonX material, the process of it starts in the lab where we work with raw materials and we find basically what works best, and then we bring it to the batch plant.
This is Icon's state-of-the-art batch plant, where we're able to produce revolutionary new materials like CarbonX at commodity pricing. There's no other facility in America that offers this level of precision and flexibility in the materials we use.
CarbonX is 42% lower carbon than our previous iterations of printable materials. We partnered on a study with the MIT Concrete Sustainability Hub to take a look at the sustainability of our printed homes and compare them to traditionally built homes. And so today we can definitively say that Icon has the lowest carbon form of construction on a life cycle basis. And the crazy thing is that we're just getting started.
That is definitely the sexiest video about concrete you have ever seen, for sure. We're very proud of the progress that we've made on the CarbonX material. And in fact, as of April of this year, this will be the default building material of Icon going forward, CarbonX 1.0 or better going forward, full stop. These claims are rather extraordinary. Fastest, most affordable, most sustainable. And so as was mentioned in that video, we wanted some very rigorous third-party validation. So we partnered with the most prestigious concrete sustainability research group. And this very week, it's live online. Now you can read all the details. That may be more detail than you want in this presentation. But the conclusions of their research are that the Icon way of building with CarbonX is the lowest carbon way to build at scale, period. We've been able to do this without compromising those performance commitments we told you about earlier. We retain our 2-hour fire rating and also a 250-mile-an-hour wind rating. So we now feel like this is a material we're ready to scale up with. And so, to sort of recap a bit here, fastest, most affordable, most sustainable, sort of this Vulcan construction system. We think this is the most fully functional, capable robotic construction system the world has ever seen. We are delivering single-story wall systems at $34 a square foot. And if we ended the show here, it's been a pretty good day for the future of construction. But we're not ending here. Some of you are out there asking yourselves, not bad, that whole 90% cost reduction, but shouldn't homes be even more affordable yet? And what about multi-story construction? What about high-density projects? All the homes in my neighborhood are 2 stories. And what about like the rest of the home? Nice work on the wall system, Icon. What about the foundations? What about the roofs? What about the whole rest of the home? I'd like to show you something. I'd like to introduce you to Phoenix, Icon's next generation robotic construction system. This is the most sophisticated and advanced engineering we have ever done, and it is designed to solve all of those problems that I just told you about, reducing costs even further, introducing multi-story 3D printing construction to the world, and automating more than just the wall system, getting down into the foundations and into the roof structure as well. To pull this off, a few major innovations were needed. One is dynamic stabilization. You know, one of the great things about the gantry is very stable and accurate and easy to control in three-dimensional space. But when you put a print head out on the end of a 75-foot robotic arm, you introduce the movement of the system and the unpredictable movement of the environment and wind. Very, very difficult to get sub-millimeter accuracy on a print, which is what we demand for residential construction. This is by a mile, this is the most sophisticated and challenging engineering we've ever attempted. This is like our version of landing rockets. There were investors, some of probably in this room, investors and board members that did not believe that this was possible. I heard a board member giggle. Also, as you get higher off the ground and get away from human beings, you have to automate more and more of the task. This has the side benefit of reducing costs further, but we had to put on a whole new suite of sensors and especially computer vision, so Phoenix was able to check its work and make sure it's printing accurately, make decisions about its work once it gets out of eye line of a human being. And those sensor suites also made possible another very, very important innovation, which is automating the printing of the reinforcement. You can no longer have a human being climbing up and placing rebar manually during the print. The Phoenix has to reinforce its prints as it goes all the way top to bottom. Additionally, as you make this thing bigger, you can't make it harder to move around. It needs to be able to be delivered to a job site on a single truck, set up and begin printing in hours. And when it's done with one print, it needs to, under its own power, with no assembly or disassembly, move over to the next job site and begin printing also within hours. In short, the capabilities that we've designed Phoenix to achieve are 24,000 square foot buildings in a single print, up to 27 feet tall, can be set up and begin printing in hours after arriving on site, can be operated by less than a single operator. In other words, one human being can operate multiple Phoenix systems at a time. Massive improvements in on-site mobility, and it has to be a true robot. What I mean by that, a true robot, my definition of a true robot is something that can sense its environment, can make decisions on its own with no human in the loop, and then can act on physical space. And Phoenix is our first true robot. But Phoenix isn't just something we've designed. What I'm here to tell you today is Phoenix is real, and Phoenix is here. Like, I mean literally here, right outside, and I'd like to formally introduce you to the next generation print system, Phoenix. In a moment, you're going to get to go outside and see Phoenix for yourself, but this is not just a show pony. This past Saturday, Phoenix completed its very first print, and I think you'll be impressed.
Form follows function here at ICON. Everything we invent, design, and create has a reason why it exists.
In the early days of ICON, when we were designing the Vulcan 2, we had so many challenges ahead of us in the additive construction world. With those challenges behind us now, we're able to really lean in and focus on a more advanced, more versatile system.
For Phoenix, we wanted to create something that was faster to set up, faster to transport, faster to move between build sites. We also wanted to create something that was bigger, physically bigger, so we could actually encompass two-story homes. We wanted something that was free from architectural constraints, that broke us out of rectangular build volumes.
Not only does this unlock different kinds of architecture, but it also brings it at a much lower cost.
So we started by deleting rails. Then we deleted a tower, and we had a tower and an X-beam. So eventually you get to what seems obvious, which is an articulated arm on a rotating base.
The hardest part about the printer architecture was the accuracy. You have the movement, the inertia, the dynamics, combined with that all the natural elements like wind, and it's a really big problem to solve.
Creating dynamic stabilization for the print head was probably the hardest engineering and control system problem we've ever worked on.
What we once thought was impossible is now a prototype in the field, printing its first full-scale structure.
Welcome to the House of Phoenix. It's going to be almost 27 feet tall and extend well over 110 feet in length.
We came up with a design that would push the boundaries of the print, from the height itself to the way the structure is sloping and cantilevering. And with that, one of the biggest challenges is the actual accuracy of the printer.
We took all the learnings from Vulcan, But we said, what if we have a more flexible system that is inherently less accurate, and then we correct for it?
So Icon's developed a tool head that can stabilize the motion and keep the tooltip exactly where we want it.
Every aspect of the system is being developed to be, to a certain degree, autonomous.
How can it be a robotic companion, a coworker, rather than a piece of equipment?
This is the first thing that Phoenix has ever printed, and it's only going to get better from here.
Ladies and gentlemen, the world could be so much freaking cooler than the world we have been building. What happens when that world that you saw in the House of Phoenix, what happens when that world is more affordable to build than rectangular boxes? Because of Phoenix, I believe we can insist on having a built world that reflects our values, that reflects our hopes, that reflects our dreams. We can insist that it be sustainable. We can insist on all the things that are in our heart, and we can insist on it for $25 a square foot. $25 a square foot for the wall system represents about a 30% savings versus conventional construction. As I said before, we can also reach below grade and print the foundations and print the roof structures as well, and we expect a similar magnitude of savings on the entire shell of a building. The future is going to be very, very cool. And so now, once again, if I ended the presentation, hasn't been a bad day for the future of construction, but we have so much more yet to do. If we look again at those construction costs related to building homes in America, with Phoenix, we're able to address those top three lines: foundation, wall system, and roof. So now, with this single automation, simple supply chain, we can address about half the cost of the home. And what next? Should we automate the kitchen and bath? Should we automate the installation of windows and doors? Should we automate finishes with like painting and finish robots? Should we automate, standardize the installation of the mechanical, electrical, and plumbing system? Should we go really crazy and invent wireless power for the home? I think we'll do all those things. In fact, there's a number of task bots already under development. But as we zoomed back out, as we were trying to decide what to do next to continue our mission, of course, we started with construction proper and the robots necessary to build, and we are robot maximalists at Icon. We believe on a job site, anything a robot can do, a robot should do. But what about the rest? You know, over on the far left there, there's definitely a strong case to be made for what do we do about the cost of land. I think this one is actually rather simple. We need to go where land is cheap, and I think humans need to start building new villages, towns, and cities again. But that's a talk for another day that we'll have maybe some things to say something about. But if you look at the rest of the process, it really is the things that happen before and after construction are really different flavors of information processing problems, right? A human being, a developer, a homeowner has information they want to communicate to an architect. An architect wants to take that information and turn it into form, to give it form. Those forms then need to be, the information about them needs to be engineered for safety. That information needs to be sent to the permitting authority. All of that information needs to go to a general contractor, a project manager, and she has to manage information about weather, supply chain, subcontractors, materials deliveries, and somehow the right information from all of that has to get to the potential homeowner or renter. And the way you solve information processing problems with high technology is software. And with software solving information problems, you don't just reduce the cost 30%. You can reduce the cost of these activities 70, 80, 90%, and you can turn them into instantaneous results. And so that's the next frontier of technology development for Icon. And we started at the beginning. And if you look there at these numbers, according to the National Association of Home Builders, you'll see it says that the average cost of design and architecture on a new home in America is $5,000. And some of you may be thinking, like me, that's a funny number. Are there some architects in the room? Any of you ever worked with an architect? Any of you ever met an architect that charges $5,000? If you do meet them, please send them to Icon and we could skip this step. What this tells me, if this is reflective of the average home that we build in America, it means that we've abandoned architecture. We've abandoned all attempt at elegant design, and in fact, that's what the data bears out. So all of us think we want beautiful homes. Every developer thinks they want a beautiful development. And so we start drawing, we start designing, we're going to get this beautiful thing, and then the budget comes back. Right? Remember those levers we talked about? We could pull, like, reduce the quality of the material, reduce the quality of the labor, and often the first lever we reach for to save on budget is to reduce the quality of design, and the results end up looking something like this. And so what has happened to this horse is exactly what has happened to our housing in America. We've gotten quasi-dystopian uniformity, cookie-cutter developments, places often the people who build these places don't want to live in them. And that's a problem. So the challenge to ICON, as we try to bring software to bear on this step, is how do we reintroduce architecture and design into the home building process without driving up the cost? Because it is hard to design a home for less than $5,000. And our solution was a digital catalog of home designs. Homes for every situation we could imagine, every size we could imagine, ranging in price from $99,000 all the way up to well over $1 million. Those designs should be ready to go and ready to deploy on a project effective immediately at no additional cost. You could have full architectural integrity at scale without increasing cost, and we call it CODEX. ICON's CODEX is our digital catalog of home designs. It's all about reintroducing architecture back into the way that we build without increasing cost. So Texas is our home. It's where we were born, it's where we've grown up, and so naturally, most of our early projects have been requests from Texas customers. And the Tex Next collection is all about reimagining and repurposing these very traditional and unique Texas designs for 3D printing and for the modern world, for the future.
Today, we introduce 4 typologies, 18 variations in floor plan within the Tex Next collection to reflect local architectural vernaculars. These are the ranch, dog trot, porch, and shotgun homes. ICON's reinterpretation of ranch introduces curved geometries on the facade of the home without compromising cost. ICON's porch house features a spacious, covered porch that wraps around the exterior of the home, providing additional living space and opportunities for outdoor enjoyment. In ICON's dog trot, the breezeway acts as a passageway between the 2 halves of the home, allowing air to flow through and connecting indoor and outdoor spaces seamlessly. In ICON's shotgun, we have updated the traditional typology and modernized it for a new demographic.
So this is our attempt to honor Texas history and Texas architectural heritage while reimagining it and renewing it for the future. The Storm Collection is our attempt to respond to this tremendous demand we felt for hurricane-resilient homes. I think we're approaching like $100 billion a year annually of natural disaster damage in this country. This, of course, is a great tragedy for the people who live there, and to compound the tragedy, you're seeing things like insurance companies raising premiums on homes in these areas or refusing to insure them altogether, which makes them even harder to build, even harder to get loans for. And so we thought we could engage with novel architecture and these advanced technologies and advanced materials to really bring some solutions to this problem.
Homes in the Storm Collection have features such as enhanced low-profile roof assembly, impact-resistant windows and doors, raised grades and slabs, reinforced garage doors, and strengthened roof-to-wall and wall-to-slab connections to withstand high winds and flying debris.
Over the past several decades, the frequency and severity of wildfires has gotten worse. It's estimated in America that about 4.5 million homes are exposed to high or extreme risks due to wildfire. So in response to all of that, we have created the Fire Collection. We're taking advantage of ICON's inherent fire resiliency and adding in additional strategies to mitigate the damage and loss due to wildfire.
The collection was designed with Class A rated roofs, enclosed garages, architectural elements to prevent the ingress of embers and heat, as well as incorporating a 5-foot standoff distance from the house to prevent any wildfire encroachment.
The Alpha Beta Collection is our response to another segment of requests that we get a lot, which is what new, innovative, and cool things can you do with 3D printing?
The Alpha Beta Collection consists of 6 open floor plans. Each are 4 to 5 bedrooms and feature light-filled interiors to blur the boundaries between indoor and outdoor living. Its contemporary design language is both logical and functional while remaining sophisticated and refined.
With the launch of CODEX, we have given the world these initial 60+ designs that we think help solve the most frequent problems we hear about from the world. We invite architects from all over the world to help us. You have communities you care about, places you care about, problems you care about, and we want your creativity, your designs, and your help making solutions available to the world. Over time, we believe this will be the most comprehensive collection of homes in the world that are ready to be built at every price point and increasingly every conceivable situation. So I won't ask for a show of hands of how many of you would rather live in one of the homes you just saw than the typical home getting built today in America. But you may have noticed that there's one important category that was not mentioned in the video that we've talked a lot about today, and that's affordable housing. And the last special announcement that I have for all of the I-99 winners today is that your designs will be included in CODEX, and every time we build one of your designs, we'll be sending you a check. And I want to make a similar offer to all the architects and designers of the world. As I said in that video, we need your creativity, we need your genius, we need your solutions to the problems that we face that you believe architecture can help us engage. We have our entire team on standby, ready to work with you to get your designs ready for 3D printing. We will put them out into the world, and every time one of your designs gets ordered and delivered, we will send you a check in the mail or maybe direct deposit. I'll have to talk to the finance department. And what I want you to imagine this enables, that over time we expect this to be hundreds and thousands of designs of homes. So in the future, you can imagine a developer who wants to build hundreds or even thousands of homes can select from a variety of possible floor plans that they think best serve the community they want to build in. And the robots, the fleet of robots will be on standby to get to work building those things. Or maybe even one more step is, what if you just uploaded the lots into the platform, and then the people who intended to live there could select the lot they wanted that they could afford and could select the home design they wanted that fit their lifestyle, that fit their budget, that fit their design preferences, and the robots would get to work building that home. Then we would have this world where the communities we build are built for the people who intend to live and inhabit those places, and I think that would be an amazing world. Last step. Why last step, Jason? It's been a lot. You're doing pretty good. The reason is I want us to leave here today with a very clear picture in our head about the comprehensive things we need to do to solve the global housing crisis, from the moment of human desire all the way to delivery. So I want to return one more time to these remaining items that I think we're going to need software to fix. If you think about all of the complexity of the human heart and what we desire in our buildings, and an architect somehow tries to express that, and then you've got to get a structural engineer to honor that but make it safe, and you've got to get a permitting authority to understand that, and then you start trying to build it, and the weather happens, and supply chain stuff happens, and COVID happens. It's an incredibly dynamic, complicated, and complex system, and I think it meets the technical definition of a chaotic system. And so any of you who've ever tried to build a home, I don't even need to take a survey, almost certainly. It was over budget and blew the schedule. Am I right? Yeah, that's what happens. The reason is not because your general contractor is an incompetent idiot. I mean, maybe they are, but let's assume you got a good one. The reason is the things going on in that process almost certainly exceed the analytical and computational capabilities of a single human being. In fact, to even have a hope of having a meaningful project come in on time and on budget, you need dozens and dozens of people perfectly synchronized and communicating perfectly, and it almost never happens. But some cool things have happened technologically in the last few years. We've seen major breakthroughs in computational power. We've seen huge advancements in machine learning, and we have seen the arrival of very powerful artificial intelligence tools. So about 18 months ago, we decided the way that we were going to solve these problems is by building an artificially intelligent system that would go all the way from the moment of human desire all the way out to building delivery. What I mean by that is we need an AI system that can understand all of the complexity of human desire, both practical and romantic. The budget, the lot size, here's pictures of houses I like, here's how many people are going to live in the home. I like to have a library, I like to drink coffee on a bench in the morning. Geographic location, who's going to permit the house. We need systems that can process all of that information, and with great iteration and great speed can output back to us concept designs that we can give some feedback, we can iterate on those designs, we can then get into the details of those designs. And once you've got detailed design, you have almost got construction documents, permits, budgets, schedules, and bill of materials. And you would have a system that could go all the way from your own desires and needs to a built product. I'd like to make an introduction. I'm very happy to introduce you to Vitruvius. This has been an unbelievable feat of engineering on behalf of the entire Vitruvius team. In order to pull this off, we had to assemble what, to our knowledge, is the largest data set of construction documents, architectural plans, floor plans, and begin a very creative and sort of enterprising training regime to get Vitruvius to function appropriately. And even as recently as like 3 months ago, we weren't sure it would be ready for today, or we weren't sure what it was we might unveil. And then about 6 weeks ago, we did our last big data upload and training run, and I was working with Vitruvius to design tree houses. I have a thing for tree houses. And this image came up, and I want to tell you what happened to me when I saw this image. So I was asking for normal tree houses, sort of the wooden tree houses, sort of attached to the tree, Swiss Family Robinson kind of thing. And then when I got one I liked, I said, just for fun, because of my day job, I said, make it 3D printed. And it came back with this image. And then and now it gave me goosebumps for 2 reasons. One, there are no 3D printed tree houses in the world. This was not in the data set. It was not possible. It learned this from the data set. This was an act of true creativity. And it floored me. Furthermore, it knew or inferred that concrete would be too heavy to attach to a tree. And so it detached the structure from a tree and put concrete pillars underneath the home. So not only did it come up with something completely novel, it understood how you might go about building it. And that's when I realized we were really on to something and we needed to release it to the world. And when you can go directly from your desires and budgets and needs and get outputs like this for free. I won't ask the architects in the room how much you would charge to draw this and how long it would take you. It transforms forever the way we will design and build things. But you've heard me talk a lot today. And perhaps rather than me explaining to you what this means for the future of architecture and construction, maybe we'll have a guest. We'll have an expert come out. I'd like to invite to the stage a man that the Wall Street Journal has called the most innovative living architect, that Time magazine has called one of the 100 most influential people on the planet, full stop. A man who has designed power plants so clean, you can put parks and ski slopes on the roof. A man who, on a budget, has designed impossible-looking twisting bridges over rivers in Norway. A man who has designed the Google headquarters in California, the Lego headquarters in Europe, and most recently and most notably for us, the El Cosmico project, complete with these Sunday homes, for our partnership with Liz Lambert out in Marfa. He is one of the most remarkable men I have ever had the privilege of meeting. He has the curious imagination of a child. He has the sort of breadth of curiosity of Da Vinci, and he has the talent and capability of the great architectural masters, and I consider him to be the greatest living architect. I'd like to welcome to the stage my friend and the chief architectural collaborator for the Vitruvius program, Bjarke Ingels. Good to see you, friend. I think, I don't care what they think, I think it would be most interesting to hear you talk about what this is going to mean for the future of architecture and the way that we build, and the floor is yours, Maestro.
Absolutely. Thank you, Jason. And thank you for all the great work you're doing for the future of the built environment. It has been a true pleasure, an adventure for myself and my team to be part of that journey. And I think maybe the best way to explain the sort of immense and inevitable potential that I see in the future of AI and architecture, which is essentially, what we are sort of a journey we are beginning by opening up Vitruvius to the world, is maybe to explain my own journey of becoming an architect. When I was in kindergarten, I loved to draw. And I did it all the time. I did it with crayons and watercolors, and I became really good at it. And my passion for drawing got me to the Royal Danish Academy of Art and Architecture, and there I had to replace my crayons with hard lines and rulers. And I lost some of the sensitivity I had with the watercolors. But in turn, I gained the possibility to create multi-point perspectives, to construct measurable isometrics. So in a way, I lost some of the control I was used to, but I gained like incredible new possibilities. So then I had to replace the rulers with a mouse. And I lost, let's say, the tactility of the physical drawing, but in turn, I gained the possibility to map different materials and textures, to make different daylight settings, to move around the 3D model. So again, I lost some of the control I was used to, but I gained a whole new world of new possibilities. And today I draw with people. I've assembled a team of 700 brilliant, talented, intelligent human designers. And I have lost the control of holding the crayon myself, but I've gained the kind of creative force of the collective intelligence of all the brilliant, beautiful people that I work with. I may prompt a team with a suggestion or an idea in the form of a conversation we have, or with a sketch, and then I'll respond to all of the ideas and designs that come back, which is not very different from what you'll be able to do by essentially prompting Vitruvius with a suggestion on an idea, and over time create this kind of creative ping pong back and forth with the suggestions that are coming. So in a way, it took me a quarter of a century to assemble my team and build the creative engine that Big is today. And this is what I see as the true potential of AI, is that what basically took me 25 years to build up will now be available at the fingertips of all of you. Like any one of you will have the potential of the creative force of 700 brilliantly intelligent artificial designers once you start playing with Vitruvius. And like this Sunday, Christopher Nolan finally got his well-deserved Oscar for Best Director. And he made a comment about how cinema is only 100 years old compared to painting or sculpture. It's cinema as a toddler. And if cinema is a toddler, then 3D printing is a baby, and AI is basically an embryo. AI was only sort of open to the world a little more than a year ago, and by opening it up to the sort of human intelligence of millions of people interacting with it, its learning curve has basically exploded. And that's what we expect to see happening with Vitruvius. It may be at an almost embryonic state, but by opening it up to the dreams and desires of millions of potential homeowners, it is about to sort of start on a very intense architectural learning curve of its own. So maybe to end, you may ask, why would an architect want to contribute to what may be the end of my profession? And it would be a good question. And I think the answer is that in my mind, the future will be designed by both human and artificial designers. And there is no better way to contribute to the future than by spending energy and attention and investment into educating the designers that will give form to that future, whether they be human designers or artificial designers. By opening up Vitruvius to all of you and the world today, we are essentially starting what I believe will be a lifelong education of the artificial architects of tomorrow. So maybe on that note, Jason, if you come back on stage, I think it could be interesting if you would take Vitruvius for a spin and maybe like show us how Vitruvius is doing in its first year of architecture school.
Amazing. What do you guys think? Should we do it? Thank you, friend. Appreciate all your help.
Thank you.
Please welcome to the stage to join me for a little demo, Charles DeHadway, the director of the Vitruvius program at ICON.
Thank you.
Charles, thanks for being here. I get very nervous when I type in front of people, so I appreciate you helping me out here. So maybe to give the audience a sense of maybe how we would interact with it, we'll do me first. But I want you to begin thinking. We're about to get you involved in seeing what Vitruvius can do. So we got, yep, we're up on the screen. Okay, Charles, let's do, by the way, I swear to you, I have no idea what I'm about to see. I know what I'm going to say. I, of course, thought about it. I knew I was doing this for I have no idea what I'm about to say. This is not in the can. This is a live demo of Vitruvius. Charles, drama. Charles, I'm from East Texas. And I've always dreamed of having a cabin in the forest of East Texas. But maybe in honor of our friend, let's have a cabin in the forest of East Texas in the style of Bjarke Ingels. Sounds fascinating project. To better understand your vision, could you tell me about the size of your family? That's maybe none of your business. Let's do a 3-bedroom, 2-bath house. Great choice for a cozy yet functional cabin. Considering the innovative style of Bjarke Ingels, Would you prefer an open living plan area that combines the kitchen, dining, and living room for more communal and interactive space, or separate rooms? Honey, what would you like? My wife is out there, can't see. Open floor plan, Charles.
How about we do some creative shapes?
Yeah,
Bjarke
very
Ingels.
creative. Yeah, very creative. This is from Bjarke Ingels. Charles, click through them, click through them, click through them. Okay. What do we got? We got 3. 1, 2, 3. Okay, so that's going to be, go to the very beginning. 1, next one is 2, next one is 3. Which one do you want to take a look at? 1, 2, or 3? Ready? 1, 2, 3. Okay, run off between 1 and 2. 1, 2. I think 1. Let's take a look at 1.
With 1?
Yeah, 1 I think is what I heard the loudest.
All right.
Let's take a look. That is East Texas for sure. Who knows East Texas? That's for sure East Texas. Yeah, let's take a look at the interiors, or the floor plan.
I'm sorry. There we go.
Here we go. Look at that. Bjarke, not too bad. You got to admit. Okay, let's try to get one more under our belt before we get the audience involved all the way. So a dream of mine, it seems crazy since I'm a CEO of a technology company, is I really would like a ranch in West Texas.
Well, do you want to see this 3D printed first?
Yeah, that's probably a good idea. Yeah, we should definitely see a 3D printed
We're
version.
Icon.
We should definitely see a 3D printed version. It's a good idea. Okay, wow. Keep going. Yes, that's the one I like. Click on that one. If it'll let you. There we go. Look at that. For the architects in the room, I will not ask how much you would charge to do that and how long it would take. Okay, now the ranch home. One more from me, and then we'll get the audience involved. So I would like a West Texas ranch home. And as an homage to our work with NASA that we haven't talked about today, let's do it in the style of a moon base.
Moon base, like a space cowboy. How about we ask Vitruvius for suggestions on style?
Yeah, I don't know which architect that style is. West Texas ranch home, moon base style for a space cowboy. What styles of architects would you suggest we draw inspiration from? For a West Texas ranch home with a moon base style for a space cowboy. It put me in parentheses. I'd suggest drawing inspiration from a blend of modernist architects and futuristic design principles like Le Corbusier, Buckminster Fuller. Yeah, I like the domes. Let's do domes and make it 3D printed right away so we can get to the audience suggestions.
There's a dome.
Go to the first one. I like the first one. We'll go quick so we can get the audience involved. Let's see that interior. Yeah, that's West Texas. Liz, that's Marfa. Amazing. Okay, let's get one for the audience. All right, everybody. What I want to know, no clapping yet, we're not done yet. We got at least one more. What kind of home should we have Vitruvius design? I heard, the most interesting thing I've heard is a hobbit hole. I don't think, this will be good because I don't think we have many hobbit holes in the training data set, I'm guessing.
Like in the Shire?
Yes, like in the Shire. That's the one. That sounds enchanting and unique. To get started, how many bedrooms and bathrooms do you envision for your Hobbit-inspired home? We'll do a 3-bedroom, 2-bath, Charles, but also I think medieval is a little bit out of fashion right now. What style should we do this Hobbit hole in? Mid-century modern, sir? Have we ever met before? I don't know your name. Mid-century modern.
Mid-century modern?
Yes.
And it asks for open floor plans. We'll do that.
Open floor plan, yeah, great. A mid-century modern Hobbit home with an open floor plan. Do you prefer Incorporating natural elements. Nature or traditional? Nature. Easy answer. Natural elements. Fantastic. Where are we doing this? Countryside, mountains, beach, forest, suburbs? Mountains is loudest, at least from up here.
Mountains?
Mountains, like Rivendell.
There you go.
Go interior and see if it, go interior on one of them, see if we got mid-century modern. Oh yeah, not so bad. Ladies and gentlemen, we could do this a long day. Charles, thank you so much for your time and all the work that your team has done. I hope the power of something like Vitruvius is almost transparently obvious to you. And so our announcement, of course, today is that we're releasing the beta out into the world. So you can go outside, and there's Vitruvius stations that you can keep playing with cocktails this evening. I hear Vitruvius works even better with a few cocktails. Also, when you registered for this event, you gave us your email. And we're using that to send you all will be the very first beta testers of the Vitruvius system. We really need you to do that testing because we use a strategy called reinforcement learning through human feedback. So as Bjarke hinted, it's going to learn very, very, very fast. You'll notice, as you use it, a few disclaimers. It's not perfect yet. There are these things in AI systems called hallucinations, and they appear in Vitruvius sometimes as the floor plan and the interiors and the exteriors don't like perfectly match. There's something funny about that. We know how to get them to perfectly match, but we had to turn hallucination down to 0. And if you turned it down to 0, the creativity went away completely. And so we've set hallucination to 20% and accuracy to about 80% because we think in this stage of the game, the creativity is the most important. And so when you use Vitruvius today at the beta launch, it goes through concept design and the early phases of design iteration. By this summer, you will be able to pick your favorite design and begin iterating rapidly on that specific design. And within the coming year, you'll be able to do detailed design work, like highlight a faucet and say, not brass, make it stainless steel. Highlight those cabinets and say, not white oak, make it walnut. That's all coming in the coming year. And once you've got detailed design, you have got construction documents. And once you've got construction documents, you've got budget schedules, bill of materials. And if you've got robots like we do, you can manifest those designs out in the real world faster and more affordably than a human being ever could. So those are the big unveils today. Not bad. Where I want to end is maybe like where I began, and that's like sort of in the human heart, which is maybe one way of saying the problem is that like the current way of building is not letting us have our dreams. But maybe the deeper tragedy of the current moment of construction is we've stopped dreaming altogether. Nobody asked for these damn rectangles that fall apart and that cost more and more every year, but we've somehow like accepted it. And what I hope today is that you can begin to believe that the real desires and dreams of your heart and those of the people you love, that those things, that you can begin to believe that those things can be true and real. And I don't mean blind faith or blind belief. I hope we have shown you that the world can be so much more incredible than the world we have been building. I hope we have shown you that you can hold on to those dreams and that we're going to do something about it. I hope you can see that the combination of AI systems and robots is going to deliver us a world that is not less human. We are about to get a world that is more human and more in tune with the things that we really want out of this world that we get to inhabit. And so let's go. We will not stop. We will build every technology necessary to make this possible. We will build it ourselves if we have to, and we won't stop until that world of our dreams is the world of our waking eyes. And for the developers of the world, we are ready to partner with you to bring this to life. For the builders of the world, we are ready to equip you. For the architects of the world, we are ready to make your genius and your designs available to the people of the world. And for those of you who wonder When are all these conversations about affordability and ugly suburbs and homelessness and sustainability, when are these conversations about something all of us share in common, which is a need for decent shelter? When are these conversations going to quit being so damn depressing? We are coming as fast as we can. We ride.